Hello students, welcome to today's class. In this class I will be discussing multiple choice questions on ionic equilibrium. This is second part of chemical equilibrium chapter. In part 1 we have discussed the concepts of only chemical equilibrium. So this is the continuation of the same chapter, equilibrium. So let's consider the questions one by one. First question, which of the following is a Lewis acid? See, Lewis acid is electron pair acceptor, whereas Lewis base is electron pair donor. Electron pair donor is Lewis base. So this is the electron pair acceptor donor theory. There is another theory that is called Bronsted acid base theory, where Bronsted acid is called proton donor and Bronsted base is called proton acceptor. So in the first option A, we have cyanide ion, negative charge either, therefore it will act as electron pair donor, therefore it is a Lewis base. In alcohol also, there is a pair of electron on oxygen atom, therefore it will also act as Lewis base. And in case of ammonia, there is a pair of electron, therefore it is also a Lewis base. If you know the Lewis octet theory, then you can easily understand how to apply the structure of molecule based on chemical bonding. See, in case of aluminum chloride, aluminum is deficient of 2 electrons to complete the octet. So it can accept 2 electrons given by an ion like Cl minus ion. Therefore, AlCl3 is electron pair acceptor, and that will be the answer for this question. So answer for this first question is D. So let's go to the next question. Second question. The pH of 10 to the power of minus 2 molar acetic acid. A value is given because it is a weak acid. So you should note that concentration of H plus is given by square root of Ka into C. So square root of Ka into C means it is square root of 1.8 into the power of minus 5 into concentration is 10 to the power of minus 2. So that comes to concentration 1.8 into 10 to the power of minus 7. So we may take this as 18 into 10 to the power of minus 8. Square root of 18 will be close to 4. So this can be approximated as 4 into 10 to the power of minus 4. So you cannot go on doing it very accurately in the competitive exams. Therefore, pH of the solution will be negative logarithm of 4 into 10 to the power of minus 4. Therefore, this will be 4 minus of log 4. Log 4 ಗೊತ್ತಿರಬೇಕು 0.6020. So that comes to about 3.4. 3.4 ಇಲ್ಲಿ ನಮಗೆ ಆನ್ಸರ್ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ, but it is close to 3.6. So why we did not get 3.6 exactly? Because we approximated the value of square root of 18 as square root of 16. So ನಮಗೆ nearest answer ಏನು ಬಂದಿದೆ ಅಂತ choose ಮಾಡ್ಕೋಬೇಕು. The nearest answer is 3.61. So that will be the answer. The next question, that is, which of the following expressions is not true? For a neutral solution, concentration of H plus to concentration of OH minus, it is a product that is equal to Kw. So first statement is actually wrong. In an acidic solution, so we should consider this second statement, concentration of H plus will be more than concentration of OH minus. That means if H plus is 10 to the power of minus 4, then concentration of OH minus will be 10 to the power of minus 14, that is Kw, divided by 10 to the power of minus 4, that will be 10 to the power of minus 10. Still concentration of OH minus will be greater than 10 to the power of minus 14, that is Kw value. Therefore, if one is greater than Kw, the other one is also greater than Kw. So they cannot be less, therefore second statement is also wrong. For an alkaline solution, concentration of OH minus is greater than concentration of H plus, but both values will be greater than Kw value. So that statement is also wrong. For a neutral solution, concentration of H plus, concentration of OH minus is equal to 10 to the power of minus 7, of course at 25 degrees centigrade, and hence we get the value of Kw as 10 to the power of minus 14. Therefore, fourth statement is correct. Answer is D for this. It is the only statement that is correct regarding ionic product of water. 10 to the power of minus 5 molar solution of 25 degrees centigrade is diluted 1000 times. So what is the pH of the solution? So you may consider the calculation of molarity. Actually it is 10 to the power of minus 8 if it is diluted 1000 times. So you may apply, if you don't know, M1V1 equals M2V2. So this is 10 to the power of minus 5, say it is 1 liter initially, and 1000 liter is added. Now what is the molarity? We have to calculate. Therefore M1 will be coming 10 to the power of minus 5 divided by 1000. That means it will be 10 to the power of minus 8. Now total concentration of H plus at this very dilute solution will be 10 to the power of minus 8 from HCl and 10 to the power of minus 7. Say this is from water dissociation, this is from HCl. So if you solve for this, this will come to 10 to the power of minus 1 plus 1.0.1. That means it will be 1.1 into 10 to the power of minus 7, total number of H plus. So pH of this solution will be negative logarithm of 10 to the power of minus 7 times 1.1. That means it will be 7 minus logarithm of 1.1. Because it is 1.1, it may be log 1 is 0, log 1 is 0. So log 1.1 may be about 0.02 or 0.03, something like that, very small value. Therefore this will be very close to something like 6.98 or something like that. So it will be very close to 7 but not 7. So the value should lie between 6 and 7. So C must be the answer for this. See, there is another logic you can use. Because it is an acidic solution, it contains very small quantity of HCl. So it cannot be neutral or it cannot be alkaline. Therefore, D can be ruled out, and also it cannot be, is 10 to the power of minus 5 means it will be, pH should be equal to 5. pH is going to change certainly, but it will come close to 7, it will lie between 6 and 7. So if you want, you may calculate like this. So total concentration of H plus must be taken from the contribution of HCl after dilution and concentration of H plus by water dissociation also. Then we are going to get an answer that is very close to 7. Therefore answer will be 6 and 7. This rule should be applied when the solution is very dilute. So another similar question is here. 10 to the power of minus 5 molar NaOH solution is diluted 100 times. So molarity of the solution after dilution you may calculate using M1V1 equals M2V2 or simply 10 to the power of minus 5 divided by 100. That means it will be 10 to the power of minus 7. So concentration of OH minus will be 10 to the power of minus 7 plus 10 to the power of minus 7, that is from NaOH and this is from water, and that will be 10 to the power of minus 7 into 2. Therefore pOH of the solution is negative logarithm of 2 times 10 to the power of minus 7, that will be 7 minus log 2. 7 minus log 2 will be 7 minus 0.3010. It will be taken as 0.3. So it will be 7 minus 0.3, that comes to 6.7. See, this is POH. What we have to calculate is the pH. So pH will be 14.0 minus 6.7. Now that comes to 0.3. So it is just above 7. So it will be lying between 7 and 8. So it cannot be very much exceeding 8. It cannot be too alkaline, tumba alkaline agiralla solution. Slightly alkaline, that's what you can guess. It is because it is containing some sodium hydroxide. Maybe at very low concentration, the value will be very alkaline, just above 7. It may not cross 8, 10, 9 agala because it is very dilute solution. So this question is similar to the previous question. Only thing is, first you get POH, then you have to calculate pH in this. At 90 degrees centigrade, water concentration is 10 to the power of minus 6. See, dissociation of water increases as the temperature increases. This is true for all weak electrolytes. Now it is given as 10 to the power of minus 6. This will also be 10 to the power of minus 6. Therefore, Kw will be 10 to the power of minus 12. So pKw, negative logarithm of Kw will be 12. See, value of pKw decreases at high temperatures. So the answer for this question is 12. For pure water, pH increases with increase in temperature. That is wrong. Actually, just now we saw at 90 degrees centigrade in the previous question, concentration of H plus is 10 to the power of minus 6. Therefore, pH will be equal to 6. Actually, pH is decreasing. pH decreases with increase in temperature. That must be correct statement. pH is not 7. Okay, it depends upon temperature, independent of the particular. It's wrong. pH increases at low temperature but decreases high temperatures. Okay, that is a correct statement. So there are two correct statements here. See, as the temperature goes on increasing, pH goes on decreasing. As the temperature goes on decreasing, pH goes on increasing. So there are two correct statements in this actually, both B and C. Then you will have another multiple options will be given. A is true, both B and C are true, both B and D are true, like that. So there are two questions which are actually correct in this. So both the B statement and D statement both are correct. So there are two correct answers here. So this is another similar question. What happens to pKw? See, pKw decreases. pKw is 14 at 25 degrees centigrade. Just now we saw at 90 degrees centigrade it will be about 12. So as the temperature increases, dissociation increases, concentration increases, the pKw decreases. Therefore pKw decreases with the increase in temperature. So again this question has two correct answers. See, pKw increases at low temperature and decreases at high temperature. So both statements are correct. So both B and D are correct. There are two correct statements in this question. So ಈ ಥರ ಕ್ವಶನ್ಸ್ ಇದ್ದಾಗ ನಿಮಗೆ ಇನ್ನೊಂದಷ್ಟು ಆಪ್ಷನ್ಸ್ ಕೊಡ್ತಾರೆ, ಲೈಕ್ ಎ ಓನ್ಲಿ ಸೇ ದೆನ್ ಬಿ ಓನ್ಲಿ ಆರ್ ಲೈಕ್ ಡಿ ಓನ್ಲಿ, and another option will be given. It will be something like both B and D are correct. So both B and D are correct. So such type of multiple options will be given. Then you have to choose the correct answer. The expression for degree of dissociation of a weak electrolyte is, say this is about derivation of the expression. So we shall consider a weak acid like HA, where it dissociates to give the anion A minus and H plus, or you may consider A particular example, say 3H3COOH dissociating into CH3COO minus and H plus. Now initially at the beginning this will be 1, this will be 0, 0, and what is going to dissociate is alpha moles of acetic acid to give alpha moles of the ions. So at equilibrium we have 1 minus alpha moles of acetic acid remaining and alpha of acetate and alpha of H plus. So if concentration is C, like 0.5 molar or 1 molar, 2 molar like that, then you have to multiply C into 1 minus alpha. This will be C alpha and C alpha. Therefore equilibrium constant can be given as C alpha times C alpha divided by C into 1 minus alpha. So C gets cancelled. So you have to remember this expression. So 1 minus alpha can be taken as 1, then this will be taken as Ka, acid constant. So Ka will be equal to C alpha square, or alpha is equal to square root of Ka over C. So we have arrived at the expression. So C transfer to the left hand side and take the square root. So alpha is square root of Ka into C. So where is the answer? So it is the D. That is the answer. You have to use this if you want to calculate degree of dissociation, or if you want to calculate the concentration of H plus, then C alpha will be equal to square root of Ka into C. Which of the following is alkaline solution? See, this is based upon hydrolysis of salts. So small amount of the salt undergoes hydrolysis to produce some H plus ions or OH minus ions. So KCl, say if it undergoes hydrolysis, then it's going to produce say KOH and HCl. See, both are strong, they produce equal amount of OH minus and H plus. So totally the solution will be neutral. The concentration of OH minus will be equal to concentration of H plus. In the question option B, sodium bicarbonate will react with water. So water jab react agate ankodi, Na plus will react with OH minus. So this will be NaOH and another will be carbonic acid H2CO3. This is a weak acid. So it undergoes partial dissociation to produce H plus, whereas NaOH will produce OH minus. So OH minus ion concentration will be greater than H plus in the option B. So that must be the answer. So in B, sodium bicarbonate solution, it will be mild alkaline solution. Ferric chloride, see if you observe ferric chloride, it becomes after hydrolysis ferric hydroxide. So weak electrolyte produce only small amount of hydroxide and this will be HCl. So it produces large amount of H plus. So H plus will be more than OH minus. So this solution C will be highly acidic. Again, ammonium acetate will be neutral solution because it will produce weak acid, acetic acid and weak base NH4OH which dissociate to the same extent. See, Ka value is equal to Kv for ammonium hydroxide and acetic acid. Therefore, they produce equal amount of H plus and OH minus. So, ammonium acetate solution will be neutral. So, for answer for this question, which will be alkaline anta kelidre, that will be sodium bicarbonate. The pH of a solution obtained by mixing 10 ml of 0.1 molar NaOH and 20 molar 0.1 molar HA. HA is a weak acid, Ka kotirodrinda weak acid anta ankobeku. Now the concentration of NaOH is 10 ml milliliter into 0.1. If you multiply that, that comes to 1 millimole. See, 1 millimole is nothing but 10 to the power of minus 3 mole. You may rewrite it as 1 millimole. Similarly, concentration of H plus in the given solution is 20 ml into 0.1, that comes to 0.2 millimole. Because we are adding a strong base NaOH, if to neutralize all the acid completely, 0.2 millimole. Now when they are going to react with each other, 2 millimoles, when they react with each other, 1 millimole will be neutralized, 1 millimole of H plus remains as it is. So it will be remaining as it is. Now we have to calculate the pH of this solution. So concentration of H plus ions will be 10 to the power of minus 3 mole. Now Ka value is given here, therefore you apply the formula C into square root of Ka into C. So ಇದನ್ನು apply ಮಾಡಿ, concentration of H plus is square root of Ka into C, 10 to the power of minus 3 millimoles multiplied by 1.6 into 10 to the power of minus 1. That is why the value of K is given in this. So this will be 1.6 into 10 to the power of minus 8. We may take it as 16 10 to the power of minus say 9. So this will be 4 into 10 to the power of minus 4.5. Then pH value will be 4.5 minus of log 4. So when I solve for this, then you will understand log 4 is 0.60 approximately. So if you subtract, you are going to get somewhere about 3.9. So pH of this solution will be about 3.9. So first what I did, I calculate the concentration of OH minus ion, that is volume of the solution into molarity. So that gives you the millimoles of the OH minus, and then you have to calculate the concentration of H plus similarly. So concentration of OH minus was 1 millimole, concentration of H plus ions from the weak acid is over 2 millimoles. So 1 millimole will be neutralized and another 1 millimole of H plus will be remaining as such. And then we have to calculate H plus ions actually undergoing dissociation will be Ka into C. So then we are going to get this much. So the pH will be negative logarithm of this value. Then if after calculating you get the pH as 3.9. So you have to remember the pH of 1, 2, 3, 4, 5. After that you have to remember logarithmic values. So 3.9 ilide anta nodi. Yes, here is 3.9 and that will be the answer. pH of 1 molar ammonium hydroxide. So we shall apply the same formula. Now concentration of OH minus ions, here will be square root of, okay, this should be Kb into C, square root of 1.8 into 10 to the power of minus 5 into 1. So 1.8 into 10 to the power of minus 5, again approximate this at 10 to the power of 18 into 10 to the power of minus 6. So square root of 18 approximate agi 4 anta tagomadi, need not do it exactly, therefore this comes to 4 into 10 to the power of minus 3. Therefore pOH of this will be 3 minus of log 4. So 3 minus of log 4 is 3 minus of 0.6, that will be 2.4. See, this is the value of pOH. So pH will be 14.0 minus 2.4, so that comes to 11.6. So 11.6 is the pH of the solution. Namge 11.13 and the answer ಕಾಣಿಸ್ತಾ ಇದೆ, that should be taken as the answer. So ನಮ್ಗೆ ಯಾಕೆ exact 11.13 ಬರಲಿಲ್ಲ ಅಂದ್ರೆ, because we approximated the square root of 18 as square root of 16. ಹಾಗಾಗಿ ಸ್ವಲ್ಪ ವ್ಯತ್ಯಾಸ ಬಂದಿರುತ್ತೆ ನಮಗೆ. So nearest answer is 11.13. So ಈ ತರ approximation ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮಗೆ ಫಾಸ್ಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡೋಕ್ಕೆ ಆಗುತ್ತೆ. Which of the following constitutes a buffer when dissolved in water? 500 ml water. Okay, whatever be the volume. 0.05 mole of NaOH and HCl, they will simply neutralize each other, react with each other. So pH will be 0. It will not be constituting any buffer. Here is salt of strong acid, weak base and strong electrolyte. So it cannot be the answer. So here is a weak acid, propanoic acid. So there is weak acid in the option C, plus salt of weak acid with a strong base. So sodium propanoate is the salt of propanoic acid and sodium hydroxide. Therefore C can act as a buffer. See, this can act as a buffer. Here is acetic acid and sodium hydroxide. Acetic acid is not a salt. Once again, only a neutralization reaction takes place. So D cannot give you a buffer. So answer for this will be mixture of propanoic acid and sodium propanoate. Which of the following can be used as a buffer solution? See, sodium chloride on dissociation gives Na plus and Cl minus. So they will not combine with OH minus and Cl minus to undergo unionized molecules. They will not combine with the acid or a base. Therefore it cannot be answered. Ammonium chloride, say it is a salt of ammonium and chloride ion. Ammonium ion may combine with certain OH minus to produce NH4OH, but Cl minus will not combine to produce undissociated molecules. Therefore B cannot be an answer. Sodium acetate, see, sodium acetate produce small amount of acetate and Na plus. So in the option C, this may combine with H plus ions to produce some amount of CH3COOH when acid is added, but sodium does not combine with OH minus, they remain as ions. So C cannot be the answer. In the option D, on dissociation we are going to get acetate ions and ammonium ions. See, if I add little amount of H plus, it will form some undissociated CH3CO minus, say, acetic acid. If I add little amount of a base, they will combine to form undissociated ammonium hydroxide. Therefore, a solution containing ammonium acetate can act as a buffer because it is a salt of a weak acid plus weak base. A salt of weak acid plus weak base can act as a buffer. Actually, it acts as a neutral buffer. So it will maintain the pH of the solution around 7. A solution containing weak acid and salt of its conjugate base has a maximum buffer capacity. See, buffer formula is given by Henderson's equation. pH is equal to pK plus logarithm of concentration of the salt divided by concentration of the acid. If concentration of the salt is equal to concentration of the acid, then it comes to pH is equal to pK. So only here you are going to find that there is a maximum buffer capacity. So buffer capacity is the amount of acid and a base that you have to change the pH of the buffer by 1, that you have to add acid and a base to change the pH of the given buffer by 1 unit. That means if there is a pH of 6, to make it of, say, pH of 7, how much of the base you are going to add. So that is called buffer capacity. So maximum buffer capacity is observed if salt concentration is equal to the acid concentration. So that will be the answer. A solution of 0.1 molar copper sulfate. See, copper sulfate undergoes, say, hydrolysis of the salts. So it is going to produce cupric hydroxide and, say, sulfuric acid. Then of course 2 mole of water. This will be weakly undergoing dissociation, whereas this will be undergoing complete dissociation. Concentration of H plus will be more than concentration of OH minus. Therefore it will be acidic in nature. So hydrolysis of salts or salt solutions can be either acidic or alkaline or basic depending upon the hydrolysis of the ions. So similarly, sodium cyanide. See, sodium cyanide, you may imagine NaCN reacting with water to produce, say, NaOH and HCN. HCN is a weak acid, produce small amount of H plus. NaOH produce large amount of OH minus, therefore OH minus is greater than H plus. Therefore the solution will be alkaline in nature. A solution of ammonium acetate obtained by mixing equal volume of equimolar solution of acetic acid and ammonium hydroxide, given that Ka and Kb of amino acids are equal, so it should be neutral in nature. So whatever the concentration of H plus produced by dissociation of acetic acid will be equal to the concentration of OH minus that is produced by ammonium hydroxide. So the equilibrium constants for these equations are given as Ka and Kb, and it is given as Ka equals Kb. That means the degree of dissociation is same. Therefore H plus and OH minus ions are same. Therefore the solution will be neutral in nature. So pH will be nearly equal to 7. Ksp of a metal hydroxide, so M anta kottidare, take it as a metal hydroxide, is 3.2 10 to the power of minus 8. Calculate the pOH when it is suspended in water. So we have to calculate like this. Metal hydroxide undergoes dissociation to produce a metal of charge 2 plus and 2 OH minus. So this will be S and this will be 2S, where S is the solubility. Therefore Ksp is equal to S into 2S square, that is 4S cube. Therefore 4S cube will be equal to 3.2 into 10 to the power of minus 8. Therefore S cube is equal to 3.2 into 10 to the power of minus 8 by 4, that will be 0.8 into 10 to the power of minus 8. Now we have to take S. S is cube root of that, so I will write this as 8 into 10 to the power of minus 9. Cube root of 8 will be 2, and cube root of 10 to the power of minus 8 will be 10 to the power of minus 3. Usually competitive exams ಅಲ್ಲಿ cube root ತುಂಬಾ ಈಸಿಯಾಗಿ ಡಿರೈವ್ ಆಗೋ ಥರನೇ ಕೊಟ್ಟಿರ್ತಾರೆ. Now this is the value of S. Therefore concentration of OH minus is 2S. So 2S ಅಂದಾಗ now we have to take it as 4 into 10 to the power of minus 3. Now what will be the pOH of this solution? You have to calculate. ನೋಡಿ ಫಸ್ಟ್ ಏನು ಮಾಡಿದ್ದೀನಿ ನಾನು, have calculated the S value, that is solubility. Solubility, you have to use the relation 4S cube is equal to Ksp for this, because it is Ap2 type of salt, and we get OH minus S value as solubility as 2 into 10 to the power of minus 3, but concentration of OH minus is 2S, for 4 into 10 to the power of minus 3. So what is the value of pOH? That will be negative logarithm of 4 into 10 to the power of minus 3. So that will be 3 minus log 4. So log 4 is 0.6. So it will be 0.6. That comes to 2.4. See, pOH anta kelirodinda illige stop ಮಾಡಿ answer no problem. So we take it as 2.4. Suppose pH anta kelidre, then you have to subtract 2 pH 14 minus 2.4 ಮಾಡಬೇಕು, but the question given is 2.4. Therefore answer is B. The solubility product of calcium phosphate is given as. So you can answer this question if you know the formula of calcium phosphate. Calcium is 2 plus, phosphate is PO4 3 minus. So interchange the numbers, then you are going to get the calcium phosphate formula Ca3 PO4 twice. Then for its suspension in water, that means its precipitate, will be 3 calcium 2 plus and PO4 3 minus, so that will be 2. Therefore Ksp value will be concentration of calcium 2 plus cubed and calcium phosphate ion squared. So if you find that answer, that will be expression for Ksp. So C is the answer. So in others, there is one or the other wrong thing. Will you see a 2 plus quotidian, therefore it will be wrong. The solubility of mercurous chloride in water. So the mercurous chloride and tashna ನಾವು Hd2Cl2 ಅಂತ ಬರೀತೀವಿ. But when it undergoes dissociation or its suspension in water is Hg2 plus and 2Cl minus. ಇದನ್ನು ನೀವೇನಾದರೂ 2Hg plus and 2Cl minus ಅಂತ ಬರ್ಕೊಂಡ್ರೆ you will get the wrong answer. So Hg2 will be remaining as such. Nodi mercury ion will be bonded like this and each mercury carrying 2 plus, therefore we get this type of ion. So this will be S and this will be 2S, therefore Ksp will be equal to 4S cube because it is Ab2 type of salt. So Ab2 type of salts ke ade tara barutadu 4S cube. Therefore solubility and the S, or the value of S, that will be cube root of Ksp divided by 4. So iದ್ರ ಮೇಲೆ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿದ್ವಿ previous usually. So that is the answer. So ಇಲ್ಲಿ brackets ಕೊಟ್ಟಿದ್ದಾರೆ, bracket ಕೊಟ್ಟಿದ್ದಾರೆ, it applies to whole cube root of Ksp by 4. So C is the answer. S1, S2, S3, S4 are solubility of AgCl in water. 0.01 molar calcium chloride, 0.01 molar NaCl and 0.05 molar silver nitrate respectively. See here, you have to apply lay sharply a principle and then discuss the answers. Silver nitrate dissolved in water, AgNO3 in water. Say it produces Ag, or it is AgCl. AgCl produces Ag plus and Cl minus. So in water. Now calcium chloride produces 0.01 molar calcium chloride will produce 0.02 molar Cl minus. Therefore equilibrium will be shifted backwards. Whereas 0.01 molar NaCl produces 0.01 molar Cl minus. So again equilibrium will be shifted backwards, but not to the extent as it is done in the calcium chloride. So it is ಸ್ವಲ್ಪ ವಾಪಸ್ ಹೋಗುತ್ತೆ, not to that extent. Therefore solubility will be more in water and less in calcium chloride. So it will produce 0.02 molar chloride ions. Whereas the last one, 0.05 molar silver nitrate, is going to produce 0.05 molar Ag plus. So that will shift the equilibrium backwards to a largest extent. So chloride silver ion concentration or chloride ion concentration decreases because of Le-Chatelier's principle. So it depends upon how many chloride ions. As the chloride ion concentration increases, solubility decreases. The chloride ion concentration increases, solubility decreases. So it is highest in case of water, therefore S1 will be greater than the 0.01 molar NaCl, and that will be greater than 0.02 molar calcium chloride, which is producing more chloride ions, and then 0.05 molar silver nitrate because it produces very high amount of silver ions. So equilibrium more towards left side. So answer will be S1 greater than S3. See, this is S1 greater than S3, S3 greater than S2. This is S3, this is S2, and this is S4, and we have to choose the corresponding answer. See, B is the answer. Ksp of AgCl is given, Ksp of silver chromate is given. Which ion is precipitated first when solid silver nitrate is added? See, if ionic product becomes greater than Ksp value, then precipitation takes place. That is a condition for precipitation. So precipitation occurs if ionic product exceeds the solubility product. Remember, here it is solid AgNO3 is added. Solid AgNO3 will produce very large concentration of silver ions. Therefore, both are going to be precipitated. So we cannot predict which is first and which is later. So both are going to be precipitated. Ali, instead of solid, if they had given it as a 10 to the power of -4 molar silver nitrate, aವಾಗ ನಾವು ಅದನ್ನ calculate ಮಾಡಬೇಕು which one will be greater, because sodium chloride is containing, see, one solution containing 0.1 molar Cl minus, another solution is containing 0.1 molar chromate ions. So chromate ions are there. This will be Ag2, silver chromate, and for which it will be going to exceed the solubility product, we have to calculate. But 10 to the power of -4 and the they have given it as solid AgNO3. So it produces very high concentration of silver ions. Therefore, for both salt solutions, the ionic product exceeds the solubility product. So both are going to be precipitated. So answer for this question will be C. Solubility of magnesium hydroxide in pure water is 8.10 to the power of -5 per 500 ml of water. So what is the solubility is given? You have to calculate the solubility product. So I'll apply the formula M1V1 equals M2V2 to calculate solubility in 1 liter. So M1 is equal to M2 is nothing but solubility 10 to the power of -5 for 500 ml divided by 1000 ml. So that will be 4.1 10 to the power of -5. So that is nothing but the value of S. Now Ksp is nothing but 4S cube, because magnesium hydroxide is of the formula Ab2. So Ab2 types of salts are 4S cube agate. That comes to 4 into 4. In the 4.1 the 4 anta barkoli 4 cube in 10 to the power of -5 cubed. So that will be 256 if we calculate 10 to the power of -15. So ಅದಕ್ಕೆ ಕ್ಲೋಸ್ ಆಗಿರೋ ಆನ್ಸರ್ ಎಲ್ಲಿದೆ 2. Okay, if you rearrange 2.56 into 10 to the power of -13. So shifting the decimal point toward this side, -15 becomes -13. So answer will be B. So this is the answer. So here the molarity should be taken as the solubility S. Ksp of silver iodide is given in water. So what is the solubility in 0.1 molar Ki? See, Ksp is equal to concentration of silver ions and concentration of iodide ions, because it is Agi solid that is suspended in water or a precipitate. So Ag plus aqueous, and this will be I minus. Actually this is S, and this should be S plus 0.1 molar. That is almost equal to 0.1, because the solubility concentration of iodide ions is very, very small. So contribution from 0.1 molar Ki will be much greater than the contribution of iodide ion concentration from silver iodide. So I minus concentration 0.1 molar antane consider ಮಾಡಬಹುದು. Therefore concentration of Ag plus is nothing but the solubility, that will be equal to 8.5 into 10 to the power of -17 divided by 0.1, and that will be equal to 8.5 into 10 to the power of -16. So that will be the answer. So again the answer for this question is B. pH of magnesium hydroxide solution is 10 at 25 degrees centigrade. Calculate the solubility product. See, KSP is equal to concentration of Mg 2 plus and concentration of OH minus squared. So that's what? Nothing but the equilibrium value. pH is 10, therefore pOH will be 14 minus 10, that will be 4. Therefore concentration of OH minus is 10 to the power of minus 4. So that's what you have to substitute here. Concentration of OH minus is the value of now substitute here. So that is nothing but S. Therefore 4S cube is the value of KSP, that will be 4 into 10 to the power of minus 4. Okay, I have to square this. So this will be 4 into 10 to the power of minus 4 cubed. That will be 4 into 10 to the power of minus 12. Okay, 4 into 10 to the power of minus 12 is the answer. So that is given here. So concentration of OH minus can be obtained from the pOH, and that should be taken as the value of S. So 4S cube is the value of KSP, that will be 4 into 10 to the power of minus 12 cubic meter, and that will be the answer. The solubility product of A2X3. See, it is A2X3 type of salt. Then for this it will be A3 plus 2 ions of A and 3 ions of X2 minus. So it is something like saying Al2O3 or ferric hydroxide or ferric sulfide Fe2S3, so type of salts here. Or calcium phosphate Ca2PO4 thrice. So this will be 2S and this will be 3S. Therefore KSP will be 2S. If you know, find answer 109 S to the power of 5, you can substitute, or you will have to do the mathematics, that is 4S square times 27 S cube. So that comes to 108 into S to the power of 5. So for A2X3 salt, KSP is equal to 108 into S to the power of 5. So S will be fifth root of KSP divided by 108, and that will be fifth root of 1.08 into the power of minus 23 divided by 108. So this can solve easily. This is 100 times. Fifth root ತಗೋಬೇಕಾಗಿರೋದು ಯೂಶುವಲ್ ಆಗಿ ಈಸಿಯಾಗಿ ಸಾಲ್ವ್ ಆಗುವಂಥದ್ದು ಕೊಡ್ತಾರೆ. Fifth root of 10 to the power of minus 25. So that will be 10 to the power of minus 5. So value solubility value is 10 to the power of minus 5. So that is C. Only the answer, that is C. So fifth root ತಗೊಳ್ಳೋದಕ್ಕೆ ಈಸಿ ಆಗಿರುವಂಥ ವ್ಯಾಲ್ಯೂಸ್ನೇ ಕೊಡಬೇಕಾಗುತ್ತೆ ಈ ಥರ ಕ್ವಶನ್ ಕೊಟ್ಟರೆ. So which ion will be precipitating first? A solution containing 0.01 molar each of lead, zinc, manganese and cupric are treated with H2S that provides 10 to the power of minus 12 molar sulfide ions. So you have to imagine, say, 4 test tubes containing the concentration, equal concentration of lead, that is 0.01 molar lead ions, and this contains 0.01 molar zinc ions and 0.01 molar manganese ions, and this contains 0.01 molar cupric ions. Now you are going to add 10 to the power of minus 12 molar H2S. So that is going to produce 10 to the power of minus 12 molar sulfide ions. So for which the concentration S you have to calculate. S into S, the solubility product will be, say, lead sulfide. So they are of the type AB type of salts. So S square is equal to KSP. So this will be, here it will be 10 to the power of minus 14. Here it will be 10 to the power of minus 14 for all. So ಎಲ್ಲದಕ್ಕೂ 10 to the power of minus 14 ಆಗುತ್ತೆ. So 10 to the power of minus 14, it is less than KSP for lead sulfide. For zinc it will be less than KSP of zinc sulfide. Whereas for manganese it is 10 to the power of greater. See, it is greater than 10 to the power of minus 15 value for manganese sulfide. 10 to the power of minus 14 of cupric sulfide will be less than that of cuprous KSP value of 10 to the power of minus 36. So only for manganese ion solution, the ionic product exceeds the solubility product. So 10 to the power of minus 14 is greater than 10 to the power of minus 15. So only manganese sulfide is going to be precipitated. So ಈ ಥರ ಕ್ವಶನ್ಸ್ನ ಸುಮಾರು ಸರಿ ಕೇಳಿದ್ದಾರೆ. For all, you have to apply the formula of KSP equals S square, that is for AB type of salt. So for which solution the ionic product becomes more than the solubility product. So that will be precipitating. The maximum pH value from which 0.10 molar magnesium is not precipitated. Magnesium hydroxide is given. So it is something like, say, you have magnesium sulfate which is soluble in water. Magnesium ion concentration is 0.10. So you are going to add little amount of sodium, some hydroxide like sodium hydroxide. Then it should be precipitated as magnesium hydroxide. So that is the concept given here. So what is the minimum pH of the solution? The concentration of OH minus, you have to calculate it as S, and that will be 1.2 10 to the power of minus 11 divided by concentration of Mg2 plus, so OH minus square. The KSP is equal to concentration of Mg2 plus and concentration of OH minus square. From this, OH minus square will be equal to 1.2 10 to the power of minus 11 divided by Mg2 plus. So that will be 1.2 10 to the power of minus 11 divided by 0.1, means it will be 1.2 10 to the power of minus 12. Therefore, OH minus ion concentration will be square root of 1.2 10 to the power of minus 12. And this will be equal to almost minus 10, so 10 to the power of minus 10. So square root of 1.2, now 1 antane tagolli, square root of 1.2, so approximate. So square root of 10 to the power of minus 10 will be 10 to the power of minus 5. Therefore pOH of the solution is 5, or pH of the solution will be 14 minus 5. So assuming the temperature as 25 degrees centigrade, so that will be 9. So pH 9. So until that it will not be precipitated. So you are adding sodium hydroxide. Only if the pH value exceeds 9.0, then only it is going to be precipitated. Then the value ionic product exceeds the value of this 10 to the power of minus 11. So the pH value is 9. So that is the answer for this question. conjugate acid of. See, this is from the Bronsted theory of acids and bases. Now NH2 minus should be taken as a base. That is what it is given. Base is a proton acceptor. So after accepting a proton, it becomes NH3. See, this is conjugate acid, you have to find out. Therefore NH2 minus is a base. So after giving a proton to that NH2 minus amide ion, it becomes NH3. So the answer will be A. So this is based upon Bronsted theory of acids and bases. But ಅದೇ ತರ ammonia ಕೇಳಬಹುದು. NH3, what is the, if you consider this as a base, after adding H plus it becomes NH4 plus, that will be conjugate acid of ammonia. Similarly for ammonia can give, if you take this as acid, ammonia is taken as acid, and if you remove a proton it becomes amide ion. So that will be conjugate base of ammonia. So conjugate base ಕೇಳಿದ್ರೆ ಪ್ರೋಟಾನ್ ತೆಗೆದುಬಿಟ್ಟು ಆನ್ಸರ್ ಮಾಡಿ, ಕಾಂಜುಗೇಟ್ ಆಸಿಡ್ ಕೇಳಿದ್ರೆ ಪ್ರೋಟಾನ್ ಆಡ್ ಮಾಡಿಬಿಟ್ಟು ಆನ್ಸರ್ ಮಾಡಬೇಕು. So answer for this question will be ammonia. So compound that is not a Lewis acid is, the boron trifluoride is electron deficient. You can see here it is having only 6 electrons around central atom, so it is electron pair acceptor. Aluminum chloride is widely used in Friedel-Crafts reactions because it is a Lewis acid, so it needs to complete the octet by accepting a pair of electrons. CCl4 is electron precise. You can see here all are bond pair electrons. It is having 8 electrons around it, so it is electron precise. It will neither accept a pair of electron nor donate a pair of electron. Whereas SnCl4 can use its d orbitals and it becomes SnCl6. It can accept 2 lone pair electrons at a time. Therefore it is also electron pair acceptor. So SnCl4 is also Lewis acid. Which of the following is not a Lewis acid? It will be CCl4. Similarly, you may consider say beryllium chloride. Beryllium chloride also will not accept any pair of electrons. CCl4 is the answer. pH of water is 6.5. Therefore, what is the temperature? See, concentration of H plus increases if temperature increases. See, when you go on heating, concentration of H plus and OH minus increases, therefore pH will decrease. Because we take negative logarithm value, the pH is going to decrease. Therefore temperature should be more than 25 degree centigrade. So that should be the answer. So that completes the questions on ionic equilibrium. See, mainly the questions will be from solubility, product and buffers in this. And if you get a very simple question, that will be based upon Lewis acid base theory or the theory of conjugate acids and bases. So I have discussed majority of the questions from the solubility product or sparingly soluble salts. So that completes the equilibrium chapter. Thank you.